This video covers Section 5, Caching Strategies. Caching has two primary strategies, lazy loading and write-through. The lazy loading strategy updates the cache only when necessary, as in a cache hit or a cache miss scenario. Use lazy loading when you have data that will be read often, but written infrequently. For example, in a typical web or mobile application, a person might update their profile only a few times per year. However, the profile might be accessed throughout the application dozens or hundreds of times a day, depending on the user. The write-through strategy adds data or updates data in the cache whenever data is written to the database. Use a write-through caching strategy when you have data that must be updated in real time. Think of this strategy as being proactive. You can avoid unnecessary cache misses when you have data you know will be accessed. A good use case for this strategy is any type of aggregate, such as a top 100 game leaderboard, the top 10 most popular news stories, or even recommendations. Because a specific piece of application or background job code typically updates this data, it's straightforward to update the cache also. With lazy loading, only requested data is cached. An advantage is that lazy loading avoids filling up the cache with data that isn't requested. Additionally, node failures are not fatal. When a node fails, a new empty node replaces it. The application continues to function, though with increased latency. As requests are made to the new node, each cache miss results in querying the database and adding the data copy to the cache. Subsequent requests for this data are retrieved from the cache. The disadvantages include the cache miss penalty discussed earlier and the potential to get stale data. If data is written to the cache only for a cache miss, then the cache isn't updated when data is changed in the database. Therefore, data in the cache can become stale. This example shows the lazy loading workflow in Python pseudocode. With write-through, when you update the database, you update the cache. The advantage is that cache data is never stale because the data is updated every time it's written to the database. However, this approach has a few disadvantages. First is the write penalty. Every write involves two trips, a write to the cache and a write to the database, which adds latency to the process. Still, users are generally more tolerant of latency when data is updated than when data is retrieved. Users have a general idea that updates are more work and thus might take longer. The second disadvantage is missing data. When a new node is created to scale up or replace a failed node, the node does not contain all of the data. Data continues to be missing until it is added or updated in the database. In this scenario, you might use a lazy loading approach to repopulate the cache. Another disadvantage is unused data. Because most data is never read, the cluster could have a large quantity of data that's never read. Finally, cache churn. This is when the cache might be updated often if certain records are updated repeatedly. This example shows the write-through workflow in Python pseudocode. Here are the key takeaways for this section of the module. Caching has two primary strategies, lazy loading and write-through. With lazy loading, the cache is updated only when necessary for a cache hit or miss. With write-through, the cache is updated whenever data is written to the database. Choose a caching strategy that matches the use case for your data. That's it for this video. Thanks for watching and see you in the next video.